If the secondary circuit is completed in transformer, then it will produce a secondary current, that is basically load current. It will try to establish its own MMF, hence its own flux, which is induced by the primary, which will oppose the mutual flux through the core. Second point, in order to maintain the constant mutual flux, the primary current will increase. Third point, the component of the load current which is necessarily increased in the primary current is called the load component of the primary current. Point 4, load increased, that means I2 increased, that means flux phi2 increased, that means the opposition to mutual flux phi m will also increase. That means exciting current IE increased to maintain the mutual flux in the core, to maintain mutual flux phi m constant in the core. Point number 5, ampere turns in the secondary N2 I2 must be balanced by a load component of current I2 in the primary winding such that N1 I2 dash is equal to N2 I2. Thus I2 dash represents the component of the primary current to neutralize the demagnetizing effect of the secondary current. The current I2 dash in bracket I2 by A is a turn ratio, A is N1 by N2, is therefore 180 degree out of phase with I2, right? Now another point number 6, since E1 is the voltage induced in the primary winding, it is equal and opposite to the component of the applied voltage at the ideal transformer winding. Now let V1 dash is applied voltage to primary of ideal transformer to neutralize the effect of the induced voltage E1. Therefore V1 dash is equal and opposite to E1. V1 dash is equal and opposite to E1. So V1 dash is equal to minus E1. Right? So exciting current IE, that is basically no load magnetizing current I0, IE or I0, that is equal to under root IC square plus IM square. IM is magnetizing component. Its function is to provide the required magnetic flux. It sets up or it establishes a flux phi m, mutual flux phi m in the core. So IM is in phase with phi m. Now IC, that is core loss component current, feeds IC core loss current feeds to stresses and eddy current loss in the core. IC is called core loss component because when IC is multiplied by V1 dash, it gives us total core loss. So PC, core loss PC is equal to V1 dash into IC. So IC is in phase with V1. So this is the physical circuit of the transformer, right? This is the primary winding. Here the source is connected This is the secondary winding. Here the load is connected. It's a physical circuit, and in between primary and secondary we have this soft iron core, this, right? So in this iron core flux will flow. Now equivalents, this is the equivalent circuit of the transformer, R1 X1, this is IE, applied voltage V1, this is XM, this is RC, right? This is basically XM, this is RC, right? Magnetizing component and core loss component, this is E1, this is R2 X2, this is E2, this is V2, right? Now for analysis purpose we need to approximate this equivalent circuit for the ease of calculations. So I can refer whole circuit to one particular side, right? Here primary and the secondary are isolated, so analysis will be complicated, difficult. So whole circuit can be referred to one particular side, either primary side or secondary side. So let me refer this secondary side to primary side, let me refer the secondary side to primary side, then it will be R2 dash, X2 dash, I2 dash and V2 dash, and primary circuit will remain as it is, right? R1 X1 I1 V1, and shunt branch as it is, right? XM RC IC IM IE same. So this is the equivalent circuit which is referred to primary, right? For further simplification, shunt branch can be shifted at one of the two ends, because for large kV rating transformer, drop due to exciting current can be, voltage drop due to exciting current can be neglected, right? So example 100 kV transformer, right? So I am shifting this shunt branch, to primary side, right? So when I shift this to primary side, shunt branch is now primary side, it is shifted to primary side. Now R1 X1 R2 dash X2 dash, this is I1, this is applied voltage V1, here it is V2 dash, right? So here this is IM magnetizing current, this is core loss component current, right? Okay, so this is shunt branch is shifted to source or supply side. So by doing this, you see this, the I1 drop due to primary current in the impedance, primary impedance I1 in bracket R1 plus jX1 is equal to, in place of I1 you write IE plus I2 dash, so this is IE plus I2 dash, in place of I1 put IE plus I2 dash and R1 plus jX1. So now this is I2 dash R1 plus jX1, right? So here IE in bracket R1 plus jX1 we have neglected, right? I2 dash R1 plus jX1, we were getting this, right? After ignoring this drop due to exciting current, IE bracket R1 plus jX1, this is the voltage drop due to exciting current, which is hardly 2% to 6% of the full load current. So this voltage drop will be very, very small. R1 is again very small. So IE in bracket R1 plus jX1, this voltage drop due to exciting current is very, very small. So we can neglect this. So, right? So for further simplification, shunt branch can also be neglected if kVA rating of the transformer is greater than 500. So for transformer whose rating is greater than 500, you can further neglect this shunt branch. Whole shunt branch you can neglect, including XM and RC. This whole shunt branch you can neglect for large rating transformer For the transformer having rating 500 kVA, you can neglect the shunt branch without any appreciable change in efficiency, right? You can neglect the shunt branch for large rating transformer having rating more than 500 kVA, right? You can neglect the shunt branch, right? So now the circuit can be further simplified into V1 I1, R1 X1, R2 dash X2 dash, and this is I2 dash, right? So for further you can further simplify this. For further simplification, voltage drop across R1 and R2 can be neglected. So that means ignore R1, that is very small, ignore R2 dash also, right? So finally you are left with X1 plus X2 dash, that is the reactance of the two windings. So finally you will get this is the most simplified circuit, right? So this is the most simplified circuit of a transformer. Alright, so thank you very much. Thanks for watching.